All right, so today we're doing section 1.5. It's casting and ranges. And here's the deal. Sometimes you have a variable that's one type and you want to change it to another type. So in particular, you might have an integer that you want to turn into a double, or you might want to have a double that you turn into an integer. And when we do that in Java, it's called casting. So let's say, I guess I wasn't in the writing spot. Casting is changing a variable data type. I'm going to say data type. So watch this. If I say int x equals 2.0 and I try to compile this, it's going to say that doesn't work. Okay. So it says, if you can't read it, it says, notes, Java, line 9, error, incompatible types, possible lossy conversion from a double to an int. So a lossy conversion is when you're going to lose some data. You know how you can compress files and send them over the internet? Most of the compression we use for doing that is lossless. Like you compress a report you've written because it's really big and you want to send it somewhere and you want them to open it and have it still be the same report. You don't want any of the data lost, right? That's different from a lossy compression, whereas when you take a picture with a digital camera, the original file might be 10 megabytes in size, but then when you get it, on your computer, it's just 1.5 megabytes. Because JPEG, the JPEG algorithm for compressing pictures, is a lossy compression algorithm. It gets rid of some of the information, but it's okay. Like our eyes don't mind when you take away some of the stuff. But Java is not going to let you write a program that just throws away data accidentally. So if we really needed to do this, let's make it a little more plausible. If we had a variable double a equals 2.0, and then we'd still get the same error if I tried to say, hey, later on I need to just get the integer part of that a variable. It's the same error, right? Lossy conversion from double to int. Well, we can force it by putting the word int in these parentheses right here. That's a cast. That's doing a cast. And so now it compiles fine. There's no complaints. So to cast from a double to an integer, just you put parentheses with int in there. And an interesting thing that that you should know is you don't have to write double when you're trying to convert an integer into a double. If I have a double named b, I can just put the number 8 into it, and we get no complaints. And that's because you're not losing any information if you store an int into a double. I will show you though this b variable is a double, so that casting just happens automatically. You don't have to say anything. But when you're trying to store a double into an int, you have to cast it with that int thing. All right, but you don't have to do it when you're storing an int into a double because you're not losing any information. It says, hey, I can do that. I'm going to store it there, and I'm going to add a 0.0 at the end. All right, that's item 1, casting. The next part is ranges. Int variables have upper and lower limits. Lowest possible value is integer dot min value. There's like an expression. I'll show you. So we'll print it. System.out.println integer dot min value. This is a big number. That's negative 2 billion. 147 million, blah, 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 blah. Okay, so if you need a number more negative than that, then you have to use a different variable type. and we won't need to do that in this class. And they also have a max value. The max value, you can imagine integer dot max value and change that. And the max value, similar number, but one less.
Wait, what's 647 instead of 648?
Yeah, it's 647 instead of 648.
What's an integer?
What's an integer?
Is that the same as an integer?
Integer? Oh, look at that. That's an integer. Yeah. Because it was a comment, it didn't complain, but thank you for mentioning that. It's not an integer. That'd be cool. So there's a funny thing about this. I'm going to make an integer. C equals max value. Okay? I'm going to print it. I'm going to get rid of these other prints. And then I'm going to add 1 to it. What's that little shortcut expression I could write there to add 1 to C? C++. C++. That just adds 1. So check this out. What happens when you add 1 to something that's already at its maximum? It rolls around. It goes to the smallest value. So we're going to see this in action here. It's just the way they designed it. So here's where I printed the max value. Right, this line. Then we add 1 to it. And behind the scenes, it's like, fine, you want to add 1 to the maximum value? Welcome to the bottom of the pit, buddy. And now we're at the bottom value. And so it's called rolling over or rolling around or overflowing. It's just something you need to be aware of.
So it's not possible to go higher than that number?
Not with an int variable type. Nick, is it a long? I don't know what it is in Java.
A long can store 64-bit integers.
So
that maximum value of 2 to the 32nd power.
That's 2 to the 32 minus 1, right? Yeah, so the maximum value is 2 to the 32nd power, and there's another variable type called a long. It uses more memory, and we're not going to need to use it in this class, but Nick says it's 2 to the 64 power. So that's a much bigger number. Yes, Joshua?
The minimum value minus 1 will that produce the maximum value?
Why don't we try? I've never done it. Yasha asked if we subtract 1 from the minimum value, will it become the maximum value? I bet it will. Or it'll explode. No. Yeah. It goes the other way too. So it goes both ways. All right. So we've done casting. We've done maximum, minimum values. Got a couple other things. To round a double to the nearest int, use int x plus 0.5. So this is just a tip. You know, when you, if you cast a double to an int, it doesn't round it. It just drops the decimal. I should have said that before. I'm sorry. So you've got 5.7, and you cast it into an int, it's going to be 5. It's not thinking, oh, 5.7 is close to 6. I better say it's 6. So if you want to round a double to the nearest whole integer, this is just a trick. I'll show you how it works. So double e equals 5.7, and int f equals int e plus 0.5, and system.out.println f will have, we should be 6. I'm glad that it worked. If we did it without the plus 0.5, we're just going to get 5 because it just chops off the decimal. Charlotte?
Would that work if 0.7 equals like 0.3?
Yeah, check it out. If it's 0.3, it should round to 5, right? Because the rounding rules are if it's 0.5 or higher, go up, and if it's 0.4 or lower, go down. And so this becomes 5.8, but since we're doing a cast, it just lops off the 0.8 and it's still 5. Yeah. Yeah. It's kind of an interesting little trick. I personally am not going to test it on you, but the AP people wanted me to teach it to you, and it's in one of the questions. It may or may not be in one of the questions we're going to do in class today. Now, interestingly enough, if it's a negative number, you would do a minus 0.5. If you're rounding a negative number, use int x minus 0.5. That's good enough. A little trick for rounding. That's rounding instead of just casting and losing all the decimal code. All right, are we okay? I got 3 more quick things and we're done for today. You've probably been typing in JGrasp and had things get kind of munged up, like looking like this, and you've got things and you're like, I wish my code was prettier. I wanted to teach you how to fix that. So to beautify your code, press F2. So to make your code pretty, press F2. So watch when I press F2, you may think that's also scary because there's these lines and things, but it's indenting it all according to the way you wrote the code. And we'll have other indents when there's little blocks of code that need to be indicated. Now, I don't like to leave the lines there, so then Shift F2 takes the lines away. Then Shift F2 takes the lines away. So I just wanted you to know about that. We're going to be writing more code, and sometimes it's all kind of just munged all over the place, and you're like, boy, I want this to look pretty. F2, Shift F2, you're done. This editor, I don't know. I still am glad that we're using it this year. Dr. Java had all kinds of quirks, and they hadn't updated it in like 4 years, and it barely would work. And then I went ahead and decided to use JGrasp. I cloned the whole lab, and then I saw, like after school started, that they released a new Dr. Java in August of 2019. So it might have been okay to use Dr. Java, but I was ready to try something new. So, all right. And I should have mentioned last time, that the second to the last thing, I should have mentioned last time that an arithmetic exception is what happens in Java if you try to divide by 0. So I'm going to just make it happen. And you'll see. I don't think this will happen. I don't know if it'll happen when I run. I think I should be able to compile, but anyway, we're going to get I'll see. Why does it do this to me? Sometimes it says infinity, and other times it says arithmetic exception. Let me see.
I think it depends if it's a constant over 0 or 0 over 0.
I don't know. I did this yesterday. I'm like, okay, so we are going to get there. Let's do another variable. Int g equals 9. And we'll do g divided by e. I'm so pissed. No. Anyway, gosh, I wonder what I did that was different on my computer.
I mean, it might have to be an int, but that's weird,
Yeah, here we go. Ba-boom. So maybe it was because it was a double. So if you get this error, exception in thread main, see, we're in main, java.lang.arithmetic exception, and then it says, I know it looks just like a slash, but that's divided by 0. So you can't divide by 0. If you do, then you crash. So, or you get the word infinity. I've never seen that before, but I'm glad I made it crash. So one of the problems that I had you do on Wednesday was like make sure, it was something about an arithmetic exception, and I hadn't explained that, so I wanted to explain that. So the last thing for today is something called concatenation. in print calls. So, so this is a legal call in Java. And what do you think it's going to say when I print it, when I run it?
One.
It might say 1, 2, hello. It might say 3, hello. It could crash, you know. Let's see. Like, how can you add 1 and 2 and the word hello? Okay. So let's look what this did. Java is starting at the left, and it says, all right, I'm going to concatenate. I'm going to put together these things. And I got 1 plus 2. Okay, that's addition. I can do that. 1 plus 2 is 3. And then it gets to the next plus sign, and it says, wait a minute, 3 plus hello. Okay, I'm not going to try to make a number out of that. I'm going to turn it all into text. Now we're working with text. And if we had other numbers over here, let's try it. Plus 3, plus 4. My prediction is that it would say 3 hello, 3 4. Yeah, because once it's in text mode, you're in text mode. It's not going to like go back to start adding those numbers again. Interestingly enough, if I wanted that 3 4 to be a 7, I could put it in parentheses, and that would get evaluated before it got tacked on at the end. So this should give us 3 hello 7. Yeah. So once in a print call, once you're working with text, once it's become text, it doesn't go back to a number. It's gonna stay text. But if you needed something added together, you could put parentheses around it. I had another simpler example. If we got rid of the 1 2, and we just put the 1 2 over here. So someone want to guess what would this do?
Hello, 1 2.
Hello 1 2. Yeah, and then like we did before, if I wanted it to be, something we were calculating, like your test score average is, and then we had some variables in there, you put it in parentheses, it'll turn it into a number. All right, so that's concatenation. We hadn't really covered how that works, but that is how it works, and it's going to go from left to right. All right, that's all.